So we are going to be using long division to find factors of different polynomials, which we've been doing a lot of already. But this time it's going to be, instead of by factoring or by graphing or whatever, we're going to be doing long division, which I really like long division. Hopefully you do too. But think about, with long division, if your remainder is 0, then the number you come up with is a factor, right? So if we can get a remainder of 0, we can find other factors of our polynomial. Did you have a question? Oh, I'm not up there. Sorry. Thank you. Okay, so 5-4a, long division. I'm just going to start with long division. Forget the polynomial. I want you to make sure you remember this process first, and then we'll do it with polynomials, okay? If you recall, go back to 4th grade, 3rd grade. My son isn't doing this yet in 3rd grade, but I feel like he's close, so. My son, yeah, he's pretty good. I like it. Okay, remember this? So you take 7,460 and you divide it by 5, okay? The process is, I ask myself the question, 5 can go into 7 how many times? 1 time, right? And then you multiply those. 1 times 5 is 5. And then what do I do with those two numbers? Subtract them, okay? So 7 minus 5 is 2, and then you bring down the 4. Oh, isn't this fun, guys? Back to 4th grade. I love it. Okay, then 5 goes into 24 how many times? 5 into 24?
Oh, I thought we were doing 5 3 times.
No, 24. 4 times, right? 5 times 4 is 20. And then we subtract it. Okay, so 4 minus 0 is 4. And then we bring down.
This is kind of fun.
I know, it's so fun. And then 5 goes into 46 how many times? 9 times. And that is 5 times 9 is 45. So you subtract that, you get 1, you bring down your 0. 5 goes into 10. How many times? 2 times.
That's so sad.
Which is 10.
Is that really true?
And you get a remainder of 0. Okay, so here's the deal.
That's so cool.
With a remainder of 0, that means that 1492, when Columbus sailed the ocean blue, is a factor of 7,460. 5 is also a factor of 7,460, okay? So today, we're going to come up with those factors without factoring it the same way we're used to. We're going to factor it, essentially, by doing long division, okay? So here's what we're going to do. This is fantastic. You're going to love it. So they're going to say divide x squared plus 6x plus 8 by x plus 4. How what? We skip some. We don't have time to do it all. Okay.
We're doing 5-8.
This is 5-4a. We're doing 5-8 tomorrow. Okay. So if we're going to divide this, here's how we're going to set it up. X squared plus 6x plus 8 divided by, okay, still have our little division bar thing, and then on the outside, x plus 4. Okay, now that looks a little intimidating, but all you really have to do is look at your first term, okay? You're just going to ask yourself the question, x goes into x squared how many times? What can you multiply to get it? You multiply it by what? By x, right? X times x gets me x squared. Okay, now here's the deal. There's no rule about where you put that x up top, but think of this kind of like columns, right? All of my x squareds go here, all of my x's go there, all of my constants go there. That's how I like to set it up. So because I'm multiplying by x, I'm going to get that out of there because it's ugly. Because I'm multiplying by x, I'm going to put it above my 6x because that's where my linear term is, my x term, okay? And then what you do is you multiply this whole thing, x plus 4, by x to put down below, okay? So it's the same process. It's the exact same process. Let me just get this stuff out of here so I don't have all these extra marks. Okay, so x times x is x squared. X times 4 is 4x. You with me? I took this and multiplied it by this to get x squared plus 4. Like this, right? X times x plus 4. X squared plus 4x. Okay?
Why do you put it over? I know you said it, but I didn't understand. Why are you putting the x over the 6x?
Because it's the x term, not an x squared term, right? So I just put all of my x's vertically, all of my constants vertically, all my x squareds vertically, okay? Okay, so what do we do with that now? What do you do in long division? You subtract. So we're going to subtract x squared minus x squared is 0. It goes away. 6x minus 4x is 2x. What do you suppose you do next? Bring down the 8. It's super fun. Okay, so now we're here, x plus 4. You just look at the first term, how it goes into the first term here. So x into 2x. What do we have to multiply x by to get 2x? 2. So you're going to put that plus 2 up top, and then you're going to multiply it. 2 times x is 2x. 2 times 4 is 8. You just said how satisfying it was.
I know, but that was one of the easy.
Your remainder is 0, which means x plus 2 is a factor of x squared plus 6x plus 8. If I may,
You may. You may not.
I just want you to understand where this is coming from. If we just did star method with this, we would end up with x plus 2 times x plus 4. X plus 2 times x plus 4. No, we're not doing star. You may not do star method on these. You have to do long division. Okay? Denied. So technically your answers, your zeros here would be -2 and -4. I just need you to solve the problem. X plus 2 is your answer when you divide. Okay? All right, example 2.
Oh my gosh, sweet. Okay.
Don't freak out on me. You can do this. Okay. So this is your new division problem. Shh, stay with me. Put it away. I still have that quiz, you know. It's right here. Thinking about writing your name on the top of it. I know, isn't it fantastic? Kind of feel like this evil schemer right now. Okay, so if we're going to divide this, you're asking yourself x times what will get you x squared? X, okay? Like I said, I put it above that x column. Okay, so if I'm going to multiply this by x, x times x is x squared. X times a -5 is a -5x. Now be careful. This is where the mistakes happen. What are we doing with those two binomials? We are subtracting them. So if I'm subtracting, x squared minus x squared is what? 0. But what is 2x minus a -5x? Positive, right? 2x plus 5x plus a positive, so 7x. Okay? Bring down your -30. Because you're subtracting, right? We're subtracting in the problem. This minus this. So 2x minus, this was a -5x, minus a negative is always plus a positive, right? Okay, what do I need to multiply x by to get 7x? 7. So this is plus 7 over here. So now I'm going to do that. 7 times x is 7x. 7 times a negative 5 is a negative 35. Again, be careful. We are subtracting them. Okay? So a negative 30 minus a negative becomes plus a positive. Negative 30 plus 35 is 5. And we have nothing left to pull down. That means we have a remainder. Okay? You may either write it, your answer, as x plus 7, remainder 5. This is the way the book is going to write it.
I missed that. Remainders.
Or the way that Mrs. Price is going to want it from you next year in advanced math or honors advanced math is write it as x plus 7. And then think about, this is 5 over that, right? Is how we always wrote it in regular old division. Like if I do 21 divided by 2, 2 goes into 20, 2 goes into 2 one time. 2 goes into 1 0 times, right? So we would write this as 10 and 1/2. That makes sense? Okay? So if you want to write it the way you're going to do it next year, if you don't, forget about it. Write it like this. This is the way the book's going to do it. But if you want to impress Mrs. Price next year, do it this way. X plus 7. And then your remainder is 5 over x minus 5. So you can write it like this, or you can write it like this. I don't care. One bit. This was your remainder.
No, the other 5.
This 5
Yeah.
is this.
What?
Is what? Oh. Where did that come from?
Just don't do that. Do this.
Just
Okay?
think about the more complicated.
Okay. Next one. Well, if he's gonna be all freaked out about it, then don't do it. So don't do it. My son.
Stop.
All right. Just stop freaking out for a minute and pay attention, and you'll be just fine.
Why is it
You will.
cubed?
All right. Now we're asking ourselves, x times what gets me 3x cubed?
3x.
3x squared, right? So I'm going to put that here, 3x squared, okay? When I multiply that, you're done. You get 3x cubed plus 6x squared. This is not helping you. So we subtract that. 3x cubed minus 3x cubed goes away. That should happen every single time. 9x squared minus 6x squared is 3x squared. Okay, we're going to bring down our 8x. Now you're asking yourself, x times what gets me 3x squared? What are you doing? So x times what? 3x. So we're going to put the 3x up top. And when you multiply that, you get 3x squared plus 6x. We're subtracting that. So 3x squared minus 3x squared is 0. 8x minus 6x is 2x. Move your 4 down. Okay? X times what gets you 2x? X times 2. So plus 2 at the end. And when I multiply that by 2, I get 2x plus 4, which is 0. Remainder 0 is beautiful. That means this is a factor. So your answer is 3x squared plus 3x plus 2. No remainder. Okay?
Yeah.
Okay. Something that you need to pay a little bit of attention to, because if you don't do it, you're going to get the wrong answer, is a problem like this. If I tell you to do 2x to the 4th plus 6x cubed plus 5x squared minus 45, and we're going to divide that by x plus 3. Do you see anything missing here?
A single x.
There is no x to the first term, okay? You must put it into the problem or you're gonna get weird answers. It's not gonna work out, okay? So when you lay this out, you're gonna lay it out as 2x to the fourth plus 6x to the third plus 5x squared plus 0x, right, because that's 0, minus 45. Oops. And then divide by x plus 3. Okay, now from here, it's the same problem. You know exactly how to do this. Just don't forget to put that 0x in. Okay?
What if it's missing like that?
You put in any that it's missing.
That's not a 1, that's a plus.
Oh, that was a plus. Oh, no wonder it looked
Zero, you just
funny.
put 0?
Sorry. What?
When you get to 0, you put 0?
When you get to the 0, do you just...
0x, you just put 0 in front.
Oh, up here? You'll see. You'll see how this works out.
If it's missing like an x and x cubed, you just put x.
0x cubed. Yeah, not x cubed, because x cubed is 1x cubed, right? You need to put a 0 out in front. Yeah, definitely a 0, not a 1, not just x cubed, right? 0x cubed. Okay, so let's work it out. What would you multiply x by to get 2x to the fourth?
2x to the third.
2x to the third. Okay, so we multiply that, we get 2x to the fourth here. And then 2x to the third times 3 is plus 6x to the third. We subtract. This gets us 0. That gets us 0. Okay, now here's another little added bonus for you. If there's nothing there, you pull the next 2 down because we need 2 because it's a binomial going into it. Right? What? Because you're not dividing by a binomial. Okay, so we're going to pull both of these down. Okay? 5x squared plus 0x. What do you multiply x by to get 5x squared? 5x. Okay? So we're going to multiply by 5x. We get a 5x squared plus 15x. Okay? Now again, remember that we're subtracting. 0 minus 15x is what? Negative 15x. Okay? Pull down your negative 45. What can I multiply x by to get negative 15x? Negative 15. Okay? So I multiply that. I get negative 15x. Negative 15 times 3 is negative 45. Again, we're subtracting, so that's 0 and 0, which means you have no remainder, which means your answer is this. 2x to the third plus 5x minus 15. Okay? This really isn't that bad, guys.
Actually, it's so much work.
I love it. Yeah.
When I plug the equation into the calculator, how come I get like an actual number? It gave me like 119.92.
How did you plug it in? You plugged it with x's in, you mean?
Yeah.
Oh, because when you're plugging it in with x's, it's solving for x.
Is that what x would actually come out to?
I think so. Yeah. Okay. X third plus 3, x to the third plus 3, divided by x plus 1. Okay? What do you need to make sure of on this? When we set this up, we're missing an x squared and an x, right? So you're going to set it up x to the third plus 0x squared plus 0x plus 3. Do you know how bad I'm going to feel when you guys fail this test because you're not paying attention?
Not at all.
Not bad. Divided by x plus 1. Okay? So ask yourself the question, what am I multiplying by? X times what gets me x cubed? x squared. So this is going to be x to the third plus, and now here's where if I were you, I would probably write this as 1x squared. It's x squared, right? But I feel like the 0 throws people off. So if you put the 1 in, it helps you to see like, no, I actually am subtracting something there. It's not just 0. So if we subtract this, 0x squared minus 1x squared is a negative 1x squared, or just a negative x squared. You can write the 1 in. You don't have to write the 1 in. It doesn't really matter. Then you pull down your 0x. Okay? What do you need to multiply x by to get a negative 1x squared? Negative 1x, right? Or negative x. So this would be minus x. So I get a negative x squared, or negative 1x squared if you like to write it like that. And then negative x times 1 would be minus x again. If you want to write the 1 in, I think it's helpful. So I did negative x times x is a negative x squared. Negative x times 1 is a negative 1x.
How did you get what's in red? Where did you get that from?
Oops, I'm still on an eraser. From this. Remember, you have to put in your x squared and your x, but they're zeros. Like from the last problem. Okay, so keep going. We're subtracting this. 0 minus a negative 1 is going to be a positive 1x, so we'll just call that x plus 3, okay? And then you ask yourself, what do I multiply x by to get x? 1, right? A positive 1. So multiply by 1, we get x here and a 1 here, okay? We're subtracting them. That's 0. 3 minus 1 is 2. And there's nothing else to pull down, so that's your remainder, okay? Your answer then is this. So x squared minus x plus 1 with a remainder of 2. Or if you want to go and impress Mrs. Price, you would write it like this. X squared minus x plus 1 and 2 over x plus 1. Then do this. Okay? Questions on that? That's